All right, welcome everybody. So today we are going to have a look at AWS's global infrastructure deployment types that are the edge locations and the local zones. We are going to see the different use cases that they both offer and their differences. All right, so we'll start off with edge locations. AWS has hundreds of edge locations worldwide to provide low latency access. Now, this is the keyword that you want to hold on to. Okay, so these edge locations, or sometimes known as the point of presence, they provide low latency access to end users. And by the time of this recording, AWS has more than 600 edge locations that are deployed in major cities around the globe. So these are basically AWS's data centers that will provide low latency access to end users. All right. So how do they do that? How do we provide low latency access to our end users using these edge locations? Well, because these edge locations, they handle caching of contents. Okay, so whenever a certain user requests for some content, that the request is going to go to the edge location, and the edge location is going to fetch that content if it's cached in the edge location, and then it will give it back to the end user, which lowers the latency. So it improves performance, meaning that users will have a greater experience because it lowers the latency, or it reduces significantly the distance a request will have to go to travel to fetch the data from the source. All right. So that is one of the use cases, and this edge location, it is used by different AWS services. Just to name two, it is used by Amazon CloudFront, which is our CDN or content delivery network, and it is also used by AWS Route 53, which is the DNS service or domain name system of AWS. Or, of course, other services would utilize this edge location, such as global accelerator, S3 transfer acceleration, and so on. But for now, we're just taking two examples, the CloudFront and the Route 53. They use the edge location. All right. So let's have a look into detailed concepts about this edge location. All right. So say you are distributing some video files from a certain region in this world. Say, for example, you are in the Mumbai region in India, and you are distributing this video to your users all around the globe. Okay. Now, whenever the users request for your video, say, for example, if our user over here requests the video, this user is going to get a great experience because proximity is located very close to the source or to your video. All right. But how about the other users? If this user requests for that same video, the request has to go all the way to the source, and then it has to go back again. So this can significantly increase the latency, reducing a great experience for the user. Not only to mention that, the request is going to have to go through a lot of hops. Okay, so if you're just using the public internet, so you might have several routers over here. Okay, so the request is going to go to different hops. All right, and this might also significantly increase the latency, and the connection of the delivery of the content could be very, very low. Okay, and how do we improve this user experience to our end users that are spread all around the globe? Okay, so that is where the edge locations come into play. So when our user, say for example, let's call this Sally, when Sally requests for your video content or whatever file that you are distributing to your users, the request is going to be received by the edge location first, or by the point of presence. Okay, of course, it's going to go to Sally's ISP first, and the ISP is going to forward it to the point of presence. Now, what happens at the point of presence? Well, the content is going to be looked into the cache. Okay, so if it's found in the cache, meaning that if it was previously has been requested from the same edge location, then the video or whatever the content is going to be delivered for Sally from the edge locations. Now, as you can see, we are saving a lot of distance for the request to go all the way to the source and back. Okay, and we're also saving our source from getting hit by a lot of requests. So if you have, say, for example, millions of users, the request is not going to, all the million requests are not going to come to your source, because they would be response back from the point of presence. Okay, so this is how edge locations would significantly improve the latency, or it lowers the latency and increases great user experience. Okay, how about if that video content is not found on the cache? So what's going to happen is the request is going to be received by this edge location, and the edge location is going to use AWS's global network backbone. I believe at this time it is handling about 400 gigabits Ethernet connection. Okay, so this is going to be very fast, great experience, and it doesn't have to go through all the hops for the public internet, which can significantly increase the latency, and there is a lot of dependency here because it's out of our control. But because of edge locations, this is going to be routed through the AWS's global network infrastructure, and then the response is going to go back. Now, once the response is back, first the request or the content is going to be cached over here, and then the result will be returned back to our user Sally. Okay, say for example, if another user who lives very near to Sally or to this edge location, if this user requests the same contents, a subsequent request after Sally requested, definitely this is going to be found on the cache, depending on the time to live that you configure, or TTL, for how long you want to keep that content on the cache. And then the response is going to be back to our user from the edge locations, which is the nearest edge location for the requester. Okay, so this significantly improves user performance, and this is what edge locations are used for. So mainly, one of the services that makes this happen is the CloudFront. Okay, CloudFront, as we mentioned earlier, it is the CDN, or Content Delivery Network of AWS. All right, so if you have configured your CloudFront, then all this magic is going to happen. The request is going to be received by the nearest edge location. Say, for example, if our user over here requests that, the request is going to be received by this edge location. Say, for example, for this instance, the content is not on the cache. So the edge location is going to send the request using the AWS global infrastructure to the source, and then using the same global infrastructure, it would be returned back, avoiding all the internet weather and all the hops of routers that it would go to if we use the public internet, and then it would be handed back to our user or to our requester. So experience has been improved. This is what edge locations do. One thing I want you to remember over here is that we are not deploying anything on the edge location. We are just using it for caching contents, meaning we are not processing data over there. There are no EC2 instances, there are no databases, there are no storages or EBS storage that we are doing. This is just, we are using the storage of the cloud, of the point of presence, just to cache contents for the configured amount of time we want that to live. Okay, so this is great for static websites. If you have a static website, something that does not change frequently, and then you can have CloudFront configured for that, so that it will be, the content will be cached, and the response will be returned back from the closest edge location back to the user. All right. So this is edge location, or point of presence. Next, let's have a look at local zones. All right. So local zones are physically located closer to end users, often in major cities or near data centers in metropolitan areas. Okay. So far, when we read this statement, it sounds very similar to the point of presence, but this is totally for a different type of use case. Now here, it can be located near a data center or on-premises data center. So it could be located there, or even near to end users. Okay, so by the time of this recording, AWS has 34 local zones in different metropolitan areas, and it's counting, and it's going to increase. This number is going to increase. Okay, so this concept is like is more like extending your region. We'll have a look at that in detail in the coming slides. All right, so what is used for? What is the use case? Well, it's ideal for use cases like real-time data processing. Okay, so here there is a data processing. But when we were talking about point of presence or cloud front, there was no data processing. But this time we are processing some data. We can process some data, and it is used for applications that require very minimum latency, like a single-digit millisecond latency, such as gaming, media rendering, financial applications like the stock or forex market, where very low latency is required, maybe for some virtual reality or augmented reality applications. So we deploy these applications in local zones close to some data center or close to our users so that we can get a consistent low latency. There is a word consistent over here. Okay? Consistent single-digit millisecond latency so that we can achieve the minimum requirement of that application in terms of latency. All right? Okay, let's break it down. Say for example, this is a United States map, and this is Texas. Okay, we are in Texas over here, and we have a data center in Texas. Now we have some applications. It could be a gaming applications that is used by many users, maybe in Texas region, in Texas area, or we might have some data that we want to process in real time in our data center. Okay, so let's take this as an example. And the closest region to Texas is the North Virginia region, because there is no AWS region in Texas. AWS region that is closest to Texas is the North Virginia. Okay, so if we want to use the cloud, if this company wants to use the cloud to deploy its application so that they will achieve scalability, high availability, and all the benefits that you would get by deploying your application in AWS, the request from the users or from the data centers has to go all the way to Texas, to North Virginia, and then back to Texas. So this is not going to meet the requirement of latency for that application. Okay, so what's the solution? This time, we deploy our application in AWS's local zone. So this is AWS's local zone, and we have 34 plus local zones all over the world, including in the United States and other parts of the world. Okay, so when we deploy our application here, if it's a gaming application, then our users over here, when they access that application, they simply access it from the local zone, and then the response is going to be back, saving a lot of miles and miles and miles for the request to go to North Virginia and all the way back. So which is really great. And as we said, if you have some data processing that you need to do from your data center that requires near real-time processing, then you deploy your application over here that does your data processing, and then there is going to be a very minimum latency. It could be a single-digit millisecond latency for your workload to operate or to work. Okay, so this is data center. As an example, one of the heavy users of data centers are Netflix. Netflix built this video, some rendering software on AWS, and they deployed in multiple or in different local zones around the globe. Say, for example, if you have some users of Linux, of Netflix over here, this could be a Netflix studio. These are artists that do different types of rendering for the video. And then the same application goes, if their application is deployed on this local zone, and they would have minimum latency when they are rendering the video. You can imagine when you are doing video editing, if the request has to go all the way to North Virginia and back, is not going to be a great experience for these artists to work on their videos. All right. So this is the use case of local zone. But in here, we are deploying our applications. We can run an EC2 instance, maybe if we need an RDS, a database, or anything of that sort. We can have these AWS services deployed in the local zones. Okay, so those are the main differences. All right, and these local zones, they are connected to the parent region. So in other words, it means that, say, just for this example, I know that we have 6 availability zones in North Virginia. So this is like extending your region. So we have availability zone 1, 2, 3, and so on, and you have ends availability zone over here. It acts as if it's like an availability zone. It means that you are extending your region by deploying your resources into local zones. But mind you, one thing to catch, not all AWS services run in local zones. Only a subset of AWS services run in local zones. AWS services have over 200 services, okay? So a subset of those services, they run in local zones. I'm going to leave on the description, a link on the description that tells what services run or what services are available on AWS's local zones. All right. Okay, and we have different local zones, 34, all around the globe. All right, so that's local zones. Now, as we mentioned earlier, it offers a subset of AWS services. Not all services run on local zone. So if you want a certain service that is not available on local zone, this local zone is connected to the parent region, say for example in North Virginia, so that you'll be able to utilize that from the parent region. Okay. All right, let's have a little comparison now. Let's compare them. So edge locations, content delivery. Okay, so whenever you hear an edge location, point of presence, it's a CDN and it's for content delivery via CloudFront, the CDN of AWS. And DNS resolution via Route 53 and caching. So it improves performance by caching content. Okay, so we get lower latency for content delivery, that is improved latency or better experience. Okay, and there is no data processing. One thing to note, we say that we do not deploy any kind of resources in edge locations except for Lambda at edge. We can deploy a Lambda function. It's okay if you don't know what Lambda function is. We're going to make a video on that. And if you like a video on that, please let me know on the comments so that we can make a video on Lambda. So except that one, we cannot deploy any kind of resource. This is just by caching. Okay. However, in local zones, it extends AWS infrastructure. Okay. As we mentioned earlier, we have a region. It's kind of like you're extending the region closer to a data center or to end users to provide low latency to run your workloads. Okay. And there is a processing of specific workloads near end users and data centers. Okay, so you are actually deploying applications over here. And you can store and process data in local zone using AWS services such as EBS and RDS. We have already seen that. And it provides a consistent single-digit millisecond latency for your application that require that very minimal latency. Okay, so this is the comparison of them. I hope it's clear. If you have any questions, please do let me know in the comments. All right. Thank you very much for watching. So if you find this video helpful, please consider subscribing to our channel and hit that like button. Thank you very much, and I'll see you on the next one.